So lesson 7. It says expansions, compressions. I just think of stretches and shrinks. We're going to ask ourselves, what happens if you stretch or shrink something? Okay? And what we're going to do is we're going to compare the graphs of y equals f of x, and hey, what happens if you put a coefficient in front of the entire equation? Oh, where a is positive, because if a is negative, that's also going to flip it. Let's keep it simple, Kelvin. Let's not worry about the vertical. Let's say Kelvin, let's not worry about the vertical flip. Let's just keep a positive. So for example, y equals, it says, oh, what is this a graph of? Semicircle of radius 2. Now they gave it to me here. It says write an equation which represents that. Well, no, I'm not going to put f of x, Mr. Dueck. I'm going to actually say that since f of x is the square root of 4 minus x squared, I'll put that there. That's the equation of 3 times f of x. And then it says, use a graphing calculator to sketch this on the grid. Okay, let's get out our graphing calculators finally. We've done most of these in our head, but let's see if we can't figure out what's going on here. And I'm going to go y equals and clear whatever I have there. And I'm going to do the first graph. Now the first graph is square root of 4 minus x squared. That's the original. Enter. And then this one here is going to be 3 times the square root of 4 minus x squared, close bracket. And then I'm going to hit zoom. Well, I always start out zoom standard until I figure out what's going on. Okay. Don't forget the x squared, right? I got this. I think this is the original. I got a bit of a problem here, though. This doesn't look like a semicircle, and the reason is we talked about how if I really wanted this to look like a semicircle, I would go zoom square, and that would make it look perfectly circular, and that would make it look like that. But here's what I want you to notice, okay? Here's what I want you to notice. Yes or no? We got it, Steph? No? Okay. That. All right. Okay. Folks, back here. Back here. That means I need you back here. Hello? I need you back here now. I know I'm happy that you got the graph, but now that time has passed. Okay? Look up, please. Here's how I think of this. Do you notice, don't write this down, I'm going to do kind of an explanation first. Blaine, do you notice this says that f of x is the same thing as y, they're interchangeable. You okay with that? Say yes. Yes? And on a graph, y is your heights. Yes? So when you go 3 times f of x, what you're really saying is go 3 times the heights. That make sense? In other words, what this is going to do is this is going to take all of my heights and make them 3 times bigger. So here's my original graph. Let's zoom in on my original graph. This point right here, how high am I right here? It's a trick question. So how high am I going to stay if I go 3 times bigger? 0. Put a dot there. What was the fancy word for a point that didn't move? Do you remember from last day? Invariant. And over here on the right, how high am I right here, Alex? So when I go 3 times that height, what will I get? 0. But here's the more interesting one. How high am I right here? 2. You know where it's going to end up? 6. And connect them. And yes, that's the equation for the Pope's hat. In case you wondered, but it is. He's wearing a semicircle with a vertical stretch. He is. Okay. So it says use a graphing calculator to sketch y equals 3f of x on the grid. We did that. It says describe how the 3 affects the original. First of all, did it expand, make taller, or compress, make smaller? And I'm even going to be fussier than that. I'm going to say vertically expands by a factor of 3. Every height became 3 times as high. Is that okay, Karen? Oh, so what happens to your x-intercepts? Well, how high are your x-intercepts? 0 high. What's 3 times 0 high? Invariant. What happens to the y-intercept? This is also a vertical expansion by a factor of 3. Did I want you to write? You could if you wanted to. I probably won't ask a specific question just like this. You'll get a better feel for this when you start working on the big review package. You'll see what kind of multiple choice questions you're going to see. Okay? D says, write an equation which represents y equals 1/2 f of x. Again, is the 1/2 inside the function next to the x, or is it out in front? Now, it's out in front. By the way, this is vertical. Is it on the same side as the y? So it's no longer backwards. If it was on the same side as the y, it'd be backwards. Is this on the same side as the y? No. So if you're wondering, hey, Mr. Dueck, how come a 3 actually made it 3 times bigger? Really, you could think of this as, don't write this down, 1/3 y equals f of x. And when you replace y with 1/3 y, it doesn't make it 1/3 as small. It makes it 3 times as big. Everything is still backwards. But Chelsea, we've already noticed that when we move the stuff from the y side to the non-y side, it's no longer backwards. That's what we found when we did slides, right? So that's still, everything is still backwards. It's just that this time they're giving us the stuff already moved over. So what do you think this would do here? Well, they want the equation first of all. Okay, the equation would look like this: 1/2 square root of 4 minus x squared. And it wants us to use a graphing calculator. I'm going to say no. This is going to take all of my heights and compress them by a factor of 1/2. Madeline, how high am I right here? It's a trick question. What's 1/2 of 0? Trick question. Yep. 0. Invariant. 0 high stays 0 high. Ah, how high am I right here, Madeline? What's 1/2 of 2? Thank you. That's how high that's going to be. And what about over here? How high am I? 0, 1/2 of 0, invariant. In other words, that blue graph would be the image. Well, you know what? That equation there is the blue graph. This equation is the blue graph. And now we're starting to actually do what we did with the parabola with any function. Because remember, the parabola, Steph, you never actually graphed it. You cheated, right? Where's the vertex? 1, 1, 2, 4. You had all sorts of shortcuts. We're starting to bring them here. Because I didn't graph this. I didn't plug in a bunch of x values and find the answers. I said, nah, I'll get the key points and connect them. So, it says, describe how this affects the general sketch. Vertical compression by a factor of 1/2. I'm going to stop writing a factor of. I'm just going to write by 1/2. But I guarantee on the test, if it's multiple choice, I'll use the proper phrasing, so don't let it scare you. What happens to the x-intercept? Once again, invariant. What happens to the y-intercept? Again, vertical compression by 1/2. Okay. We're going to come back to G in a second, but we're going to turn the page first. Justin, now we're looking at f of x and f of bx. This is what you get when you replace x with bx. First of all, are we replacing x or are we replacing y? X. So vertical or horizontal? Horizontal. That part, by the way, isn't backwards. When I said everything's backwards, x's are always going to be horizontal. Y's are always going to be vertical. It's the effect is backwards. Are we right next to the x? This is going to be backwards because unlike the y that we just did where they had moved it over to the other side of the equation, Karen, they haven't done that here. This is going to be backwards. So if they want us to do an equation which represents f of 4x, it would look like this. I would write the y. I would write the equals. I would write the great big square root. I would write the 4. I would even write the minus. But I'm not going to write an x. What do they want me to replace the x with? 4x all squared. Although, you know what? They wouldn't write 4x all squared. What is 4x all squared if I simplify it? They'd write 4 minus 16x squared. You'd have to kind of spot it and clue in. What's that going to do? Well, first of all, take a guess. Vertical or horizontal? Horizontal, and everything's backwards. Replacing the x with a 4x is not going to make it 4 times bigger. It's going to make it 4 times. Or if I want to say it's a compression by 1/4. In other words, how far to the right is, or sorry, how far to the left is this point, Luke? How far to the left is this point? -2. What's 1/4 of -2? Yep. This point is going to end up right there. Make it a bit bigger so you guys can see easier. This point is going to end up right there. Luke, what about the top? There's a trick question. How far left, right is the y-intercept? 0. What's 1/4 of 0? Invariant. How about this point? Well, it's 2 to the right. It's going to end up being 0.25 to the right. This blue graph kind of shrunk down and small, I know. That blue graph is y equals the square root of 4 minus 16x squared. That's what it looks like. We would say this. Horizontal compression by a factor of 1/4. Which intercepts were invariant this time? The x-intercepts or the y-intercepts? Because I asked you to. Which intercepts were invariant this time? The x-intercepts or the y-intercepts? Why? Because I asked you to. Which? Yeah, okay, I'll never get tired of that joke. I agree with you. It's the y-intercepts, so let's write invariant. What happened to the x-intercepts? Horizontal compression by, you know what? I'm doing that. For me. Semicircle, we did say touching. If you go look at the domain and range when we set it up, we said it was touching 0 high. Okay. D. D wants us to write an equation which represents 1/3 of x. Change the 3 to a 2, please. Otherwise, we get yucky numbers. So wherever it says 1/3, I'm going to change it to a 1/2 in those 4 locations. Now, if I want to write the equation, it would look like this. Y equals, the big square root would drop down, the 4 would drop down, the minus would drop down, but instead of an x all squared, I'm going to have a 1/2 x all squared. Although this would get tidied up too, this would really be written as big square root of 4 minus, what's 1 squared? 1. What's 2 squared? You know what? They would probably write it as x squared over 4. It's 1/4 x squared, but they probably wouldn't even bother writing the 1 either. They just go x squared over 4. Okay? So this is the final version of the equation. Again, just like last day, Martin, I much prefer the version with the brackets because I can see the substitution, the same as with last day. We simplified some equations. Actually, I like the other one better. So we've replaced x with a 1/2 x. That's going to give me a horizontal, but not a compression, everything's backwards, a horizontal expansion by 2. Ready, Luke? How far left is this point originally? I know, but let's use the mathematical number as well. I agree. It's -2 to the left. I agree. This is going to be a horizontal expansion by 2. Instead of 2 to the left, -2, it'll end up 4 to the left, -4. Oh, and Luke, you know what's going to happen with this one over here? 4 to the right. I could, even if I wanted to, see this point right here, which is hanging in midair. It's exactly 1 to the right. It's going to end up being 2 to the right. I could say this point is going to end up right there if I really want it to be accurate. And I could say this point is going to end up right there if I really want it to be accurate. But Chelsea, this top point here, how far left right is it? 0. And when I go 0 times 2, I still get invariant. Okay. How'd I get what? Instead of half as big, twice as big. Everything's backwards. The same way here, instead of 4 times bigger, 1/4 times bigger. Everything's backwards. What am I doing? Reciprocal. Is that okay? So let's make our little list here. Describe whether it expands. This is a horizontal expansion by a factor of 2. The y-intercept was invariant. The x-intercepts also undergo a horizontal expansion by a factor of 2. Okay? In fact, Chelsea, here's what we're saying. Compared to the original, if you replace x with bx, this results in a horizontal stretch about the y-axis. Don't you mean about the x-axis? No, if you're pulling it this way, the y-axis is in the middle. It's what's standing still, right? Imagine a piece of rubber, if you're like a balloon, if you're stretching it. And it's by a factor of 1 over b. What that saying, Chelsea, is you take the reciprocal. Okay? Ooh, so what if there was a 5 there? You're compressed by a factor of 1/5. What if there was a 1/3 there? You're expanded by a factor of 3. What if there was a 4/5 there? 5 over 4. Is 5 over 4 bigger than 1 or smaller than 1? Then it's an expansion. That's how I do the flip, and then I just say, if it's bigger than 1, it's expanding. If it's smaller than 1, it's compressing. So what if there was a 7 over 4 there? Compression by 4/7, which I would never give you because 7 is a yucky number to do math with. But in other words, if they, here's what they will throw at you. They'll put a m over n there. What's your factor? N over m. They'll give you an algebraic one. Okay? So if this is positive, bigger than 1, let me do an example. Y equals f of 3x. There's a b that's bigger than 1. Putting a 3 right here, is that an expansion or a compression? Compression, because the reciprocal would be smaller than 1. This would be a compression. Comp, for short. If b was a fraction, for example, the stretch is an expansion, and everything's backwards. Now let's go back one page to G from the previous page. I'll come back to this page if you need more time to write it down in a second. Okay? Now the problem here, and I kind of don't like the way the textbook does it, I would have preferred, instead of putting an A there, to put a 1 over A. Like I would have said, keep the A next to the Y where it belongs and then move it over. But they've already moved it over. So it's no longer backwards because they've moved it over. This results in a vertical stretch about the... Now if you're stretching something vertically, you're stretching it around the x-axis in the middle by a factor of A instead of 1 over B, because you had to take the reciprocal. Here, we've already done that when we move it over. Because, Luke, a 2 on this side would become a 1/2 on this side. By dividing it, you're automatically doing the reciprocal operation. So, if A is bigger than 1, the stretch is an expansion. If A is a fraction, the stretch is a compression. We really need to practice this. Oh, was that enough time? Sorry. Got it okay? And I'll go to G on the next page now because some of you are still writing. What's invariant mean? Less than 3, look up. Top of the page. Right at the beginning. No, I don't want less than 3. I want less than 5, Mr. Dueck. Top of the page, right at the beginning, Mr. Dueck. Yeah. What are invariant points there? Less than 5, beginning. Okay. So invariant means doesn't go anywhere, doesn't move. Okay. Let's go back here. So, page 41. Pardon me? What if A is also negative? It's going to be an expansion or compression depending on what A is, and the flip. So it says, write an equation which represents y equals negative 3f of x. Well, that would look like this. Y equals negative 3x cubed minus 2x squared minus 5x plus 6. And then, yes, Luke, I would probably go like this and get rid of the brackets. So I would probably write it as negative 3x cubed plus 6x squared plus 15x minus 18. But again here, Connor, I don't like this form. I much prefer this form because I can see the replacement. I think it says use a graphing calculator. We're not going to. Here's what I see. I see two transformations. I see a vertical reflection because there's a negative, and the negative is not inside next to the x. And I see a vertical, what's this 3, expansion or compression? Is it an expansion by 3 or a compression by 1/3? Expansion by 3. So here's how I would graph this. I would probably choose to find the invariant points first. What's going to be invariant here? What's not going to move? Anything with a height of 0. Because if you flip a height of 0, you know how high you still are? 0. And if you multiply that by 3, you know how high you still are? In other words, Luke, that's invariant, and that's invariant. That helps. And then I would probably just pick a few points. For example, this point right here. Well, that's going to shoot way off my graph. I would probably pick this point right here. How high am I right there at -1? It looks like just about 8 high. Reflect it. -8 times 3. Was it connected to the invariant point? Then connect it. Something like that. Ooh, here's a good one. The y-intercept. How high is that? Look at the scale very carefully. 6. Reflect it. -6. Factor of 3. Are they connected? Yep. Oh, this one's invariant, right? Yep. Here's a good one. How high is this one right now? -4. Reflect it. +4. Factor of 3. +12. Right? Oh, and I think it's got to dive down through the invariant point. Bear with me for a moment. Okay, something like that. It says describe how this, you know what, I'm just going to summarize. We did two things. We did a vertical reflection, and we did a vertical expansion by 3. Okay. No. The expansion was by 3. There's a negative, right? I reflected, then I tripled. It's easier to do them step by step. Trust me. It takes all of an extra half second, so you don't try to do it all at once. The time savings mixed with the amount of error, way to make dumb mistakes, not worth it. Okay. Blah 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 blah. Let's turn the page to 42. Okay. Glenn, you doing okay? Who's over there that's so interesting? The answer is no one. Stay here, right? Blaine, take a look at this here. There are two things going on here. I see a negative horizontal reflection. 1/3, is it right next to the x? Everything's backwards. It's not going to be 1/3 as big. It's going to be 3 times as big. Okay? I'm not going to worry about writing the equation. I'm just going to sketch this. And I would probably start with this point right here. This is a nice one. Right now it's at -2. Oh, you know what I would do? I would make a list. So what did we say? Horizontal reflection. And we said horizontal expansion by a factor of 3. So ready, Blaine? Right now, how far to the left? Well, what's my x coordinate right now? -2, reflect it. +2, expand it. Yep, that point will end up right there. I think the next point I'll take, Blaine, I'm going to slowly move along the graph. This one looks pretty good right here. What's its x coordinate right now? Reflect it. Expand it. Connected, connected. Connected curvy, connect them curvy. Right? They're connected curvy, so connect them curvy. In other words, Martin, I wouldn't do this. I wouldn't do a straight line. I think if the original ones are connected, I would probably do something kind of like that, to be quite honest. Because the height hasn't changed at all. How high was this point? It was still 8 high. It's going to stay 8 high because all we're changing is horizontal. Is that okay? Hey, Hannah, this point right here, it's going to stay 6 high. I'm not doing anything vertical, but what's its x coordinate, Hannah? 0. Reflect it. 0. Expand it. Fancy word? Invariant. You know what? It's going to go through there, kind of curvy. That looks like a straight line, Mr. Dueck. Draw that a little better. Kind of like that. What's the next point I would choose? I think this one here, yeah? You notice, Chelsea, I'm skipping the ones that are hanging in midair. If I was really desperate or I wasn't sure, I could also do those and kind of guesstimate. Oh, it's about 1.6. Reflect it. -1.6. Triple it. 1.6 times 3. -4.8. I can kind of do it. But let's see if we can just do it using nice clean points. So this one here, Blaine, back to you. This is a +1. Reflect it. Expand it. Connected? Yep, so connect them. Boy, that's terrible, Mr. Dueck. Come on. That's better. I'd probably do this one as well. Right now it's at -2, 2, -4. So it's going to be reflected. -2, -4. Expand it. Instead of -2, -6, -4. And it looks like it starts to bottom out there, so I'll start to curve up a little bit. Right? I definitely take the 3, 0. Reflect it. -3, 0. Expand it. -9, 0. And I think the rest of them are going to be off my graph. So I'm just going to put arrows there saying, you know, there are more, but they're not going to fit. Does this make sense, though? Imagine that black graph, flip it and stretch it. I think the red graph is what you would end up with. Okay. Blah, 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 blah. Page 43 is really where the meat and potatoes are. This is another one of those lovely summary pages, well worth dog-earing or post-it noting or something. So here's what it says. Expansions or compressions are transformations which stretch the graph vertically or horizontally. Okay? If A is a fraction, and what I'm going to do is I'm going to write an example above it, something like this. Y equals 1/2 f of x. That's what we're talking about. A is a fraction. Vertical or horizontal, and how do I know? Just by glancing at it. Vertical or horizontal, and how do I know? Just by glancing at it. If it was horizontal, where would it be? Yeah, okay, it's that easy. It's inside the function next to the x, horizontal. Anything else? Vertical. So vertical. Expansion or compression? Well, they've moved this over from the y side, so it's no longer backwards. Compression. By a factor of 1/2. And when you vertically compress it, which axis are you squishing it around? The x-axis, because that's what's staying still. Okay? No, it could be an expansion as well. Have patience. But here is my, let me think here. I can barely see this. The thin one is the original. The thick one is the compression. You can see the heights are not as big. Karen, answering your question. What if a is bigger than 1? Not a fraction. Like this. Y equals 3f of x. Vertical or horizontal? How do I know? It's by glancing at it. Vertical, because it's not next to the x inside the function. So it's going to be a vertical. Everything is backwards. That 3 would have been a 1/3 if it was next to the y, but it's already been moved over. Since it's already been moved over, Stephanie, it's no longer backwards. It's going to be an expansion by a factor of 3. Everything's going to be 3 times as high. Okay? Sorry? Because that's the example that I know we're going to generalize in a second. About the x-axis. Now, Martin, ask your question. Okay, the general template is this. Y equals a f of x. So it's really by a factor of a. Y equals a f of x. It's really by a factor of a. Yes. But can you see this graph here? Taller. Hey, what if a is also negative? So either this, y equals negative 1/2 f of x, or y equals negative 3 f of x. Those are both possibles. What if a is also negative? It will be reflected in the x-axis. And expanded or compressed, I don't know which because I need to know what a is in the x-axis. And I don't do them simultaneously. I find reflect first, then stretch. Or stretch first, then reflect. Either is fine. Question, Alex? Trying to read? Which one? X-axis, and that's also an x. All right. Let's talk about horizontals. So what if b is a fraction? For example, something like this. Y equals f of 1/3 x. Horizontal or vertical? And how do I instantly know without having to think about it? Horizontal, next to the x. So horizontal. And because it is right next to the letter that it came from, it is backwards. So it's not going to be a compression by 1/3. It's going to be an expansion by 3. And we'll generalize again, Martin, after I do these two examples. We'll do our generic one. And when you're stretching horizontally, you're stretching about the y-axis. What if b is bigger than 1? For example, y equals f of 4x. Kellen, horizontal or vertical, and how do I know? Why? Next to the x. By the way, the reason I'm saying that is eventually you'll have way more stuff, and it's nice to know by a process of elimination what you shouldn't do. Horizontal. And because it's right next to the x, Kellen, everything is backwards again. So instead of expanding by 4, this is going to be a compression by 1/4 about the y-axis. If I want to generalize this, both of these are f of bx. Y equals f of bx. And what we're really saying is it's by a factor of 1 over b. What we're really saying it's by a factor of 1 over b. If there's a 4, your factor is 1 over 4. If there's a 1 over 4, your factor is 4. The reciprocal, take the reciprocal, take the reciprocal. Oh, and what if b is also negative? Not only will there be a horizontal expansion compression, what else will there be, Kim? Reflection. Horizontal reflection. Okay? It'll be reflected in the y-axis and compressed about the y-axis. Okay? Turn the page. Here he's saying, oh, by the way, We've already moved the a over, so it's no longer backwards. If you go back to this side, next to the y, everything is backwards, which is why they're putting a 1 over a there. Is that okay? So given the function, replacing x with bx, horizontal stretch by a factor of 1 over b. I don't know whether it's an expansion or compression. Depends on whether it's bigger than 1 or smaller than 1. Replacing y with 1 over ay, or putting an a on the other side, gives you a vertical stretch. Let's try some of these. Example 1. It says, write the replacement and then write the equation. A horizontal, x or y. Horizontal, x or y. X. Expansion or compression. Expansion, everything's backwards. By a factor of 6, we want to replace x with x divided by 6, or 1/6 x. The equation would look like this. Y equals f of x over 6. That will give you a horizontal expansion by a factor of 6. B, horizontal or vertical? B, horizontal or vertical? Vertical. Y. What's our expansion factor? No, read to me. What's our expansion factor? 1/5. Everything's backwards. We would replace y with 5y. Now it would look like this, Hannah. Except we haven't left the 5 there. What have we done with that 5? Moved it over. How? What's happening mathematically between the 5 and the y? Multiplying, so I would. That's why we wrote it like this. And in that form, it's no longer backwards. Reflection in the x-axis and a vertical expansion. Okay, reflection. Oh, I got to think. If I'm reflecting in the x-axis, so here's the x-axis, that means I'm putting my thumbs here and spinning it this way. That's a vertical reflection. I saw you say y. Did I see you? We're replacing y with negative y. And vertical expansion, replacing y with everything's backwards. 1/3 y. So as an equation, Blaine, I'll get this. First, I would do this replacement. I'll get negative y equals f of x. Then I would do this replacement. I'll get negative 1/3 y equals f of x. And I'm okay with that format, but Greg, almost always they're going to want us to get the y by itself. What's the negative 1/3 doing to the y mathematically? So they're going to write it as y equals, the negative's going to go here, the 1/3 is going to be a 3 over on this side, f of x. That's the equation that has been undergone a vertical reflection and a vertical expansion by a factor of 3. D. Horizontal, x. Replace x with what? Replace x with what? I can't hear, sorry. A half or 2? Which one? Replace x with 2x. And vertical, y. Replace y with what? 4y. So the first thing that I would do is I would say we'll have 4y equals f of 2x. And I'm good with that, although probably if this was multiple choice, they would get the y by itself. They would say 1/4 f of 2x, but I can't somehow pull a 2 out or cancel stuff out. The 2 is inside the function. I don't know what the function is. Is that okay? Turn the page. Example 2, we're just going to do out loud. How does 3y equals f of x compare with the graph of y equals f of x? Vertical or horizontal? Vertical. And is it next to the y? Everything's backwards. 1/3 as high. Vertical compression by a factor of 1/3. This is why I like the replacement method, because then I can just memorize everything's backwards all the time with the replacement method. If I replace, we're going to do this one out loud as well. If I replace x with 4x, vertical or horizontal? Horizontal, expansion by 4, compression by 1/4. Which one? Compression by 1/4. Vertical or horizontal? Vertical, expansion by 3, compression by 1/3. Which one? Expansion by 3, 3 times as high. Ooh, two things here. Vertical, compression by 1/6. Horizontal expansion by 3. So you triple your x's and you divide your y's by 6, and those will be your new points. Example 4. What's going on here? Yep. How do I know it's horizontal, by the way? Because it's next to the, and since it's right next to the x, you know what? Everything's what? So it's not an expansion. Compression by a half. Oh, and I see one more thing. Horizontal reflection. Let's see if we can do this step by step, but in one fell swoop. Ready? Start here. How far, what's my x coordinate right now? -6, I think. Yes? Horizontally compress it by a half. It is -6, boys and girls. Horizontally compress it by a half. -3. Reflect it. +3. And you'll notice, Hannah, the height's not changing. I'm only moving left and right, but I'm keeping my pen at the same height. Because for this one here, it's too high. It's going to stay too high. It's -4, compress it. -2, reflect it. +2. Where the original one's connected, then connect them. What about this point right here? Fancy word? Invariant. Connect them. Oh, this point right here. +4, compress. +2, reflect. -2, connect. This point right here. Okay, we're going to deal with a decimal. Because what's half of 5? 2.5, reflect. -2.5. Oh, that's not too bad a decimal. Connect. Here, +6, compress. +3, reflect. -3, -3, connect. That red graph is the image of that black graph under this transformation. Okay. Part 1 of your homework, number 1. Two is good. 1 and 2. 5 is good. And then if you'd be so kind as to go to the next lesson, which is more of the same, more practice. And we're nearly done. Ooh, you know what? Here again, lovely summary of what we've done so far. Okay? So a few more expansions, compressions. But now let's do some of the weirder ones. Example 1. Write this equation after a horizontal compression by a factor of 3/4. Horizontal or vertical? We're replacing x with something. If we want to end up compressing by 3/4, that's what we must have plugged in. Right? So the equation is going to look like this. Y equals bracket 4x over 3 squared. Although, Sally, they would probably go, hey, what is 4 squared? 60, what is 3 squared? They'd probably write 16x squared over 9. But I prefer that myself. this equation, after a horizontal expansion by a factor of 4, horizontal, x, replace with expansion by a factor of 4. What did we replace the x with then to get an expansion by a factor of 4? 1/4 x, or x over 4 if you wanted to write it that way. And vertical expansion by a factor of 2. Vertical, y, everything's backwards, 1/2 y. So I would get this. 1/2 y equals the square root of 1/4 x minus 3. How can I move this 1/2 over? But I'm going to multiply by 2 and by 2. This is actually going to be y equals a 2 in front, square root of 1/4 x, and then minus 6. Okay. Let's leave C, turn the page. See, how far are we going here? Yeah. Again, let's do number 2 out loud really, really quick. So if I see that, horizontal or vertical? Horizontal. Expansion by 2, compression by 1/2. Which one? Expansion by 2, because everything's backwards. Here, horizontal or vertical? Looks like they've replaced the x with something, right? Replaced it with 3x. So horizontal, expansion by 3, compression by 1/3. Which one? Compression by 1/3. Horizontal or vertical? And two things. I see a vertical reflection and a vertical, oh, it's not backwards because it's been moved over already, vertical expansion by 2. Try E. What's the 2 do? Vertical expansion by 2. What's the 1/3 do? Horizontal expansion by 3. So you double your heights, you triple your x's. That'd be your new points. Okay. Jump down to example 3. The thin line is the original, the thick one is the new one. What's going on here? Vertical or horizontal? Vertical. You know what? This is a vertical compression by 1/2. They've replaced y with 2y. I'm not going to worry about doing that. You can try that in the homework. What about here? Well, I'll tell you the first thing that I notice. I think it's been flipped vertically because the straight line was on top, or sorry, the straight line was on the bottom. Now it's on the top. So I'm going to say vertical reflection. That means there's going to be a negative with the y. But not only was it flipped vertically, I think it was also flipped horizontally because the curvy part was on the left. Now the curvy part is on the... So I think there's a horizontal reflection. Now let's check stretches. The original graph is 1, 2, 3, 4, 5 high. How high is your new graph? Count. 10? So instead of 5 high, it's 10 high. That's a vertical stretch. Vertical expansion by a factor of 2. My original graph, if I look at its width, is 1, 2, 3, 4, 5, 6, 7 wide. How wide is the new graph? 1, 2, 3, 4, 5, 6, 7. You know what? They didn't do anything horizontally for a stretch. By the way, what substitution would that be for a vertical reflection? Replace y with negative y, x with negative x, and the negative y will also have a 2 in there. Sorry, we'll have a 1/2 in there. Everything's backwards. Okay? Turn the page. Try number 1. But you know what? Nuke G and H on the next page. Two, except Nuke I. Number 3, A is good, B is good, C is good, D is good. A, B, C, D. And 6. Okay. You got about 15 minutes. Again, although I gave you a fair chunk, if you hustle, you can get almost all this done in class, because a lot of this, I want you to reach the point where you've heard me use the term glance at this and how do I know? I want you to reach the point where you almost can glance at these and I know what's going on there. If we get there, we're happy. Unfortunately, that means you got to practice a lot. Sorry. But it will save you time in the long run.